Scene script. Have you ever wondered why the ability to learn and adapt is so critical in our lives? It's a fundamental aspect of our survival and success. From the moment we're born, we're constantly learning, adapting, and evolving based on our experiences. We learn to walk, to talk, to interact with the world around us. As we grow, we continue to learn, picking up new skills, adapting to changing environments, and navigating through the complexities of life. Learning and adaptation are not just limited to humans, though. In the fascinating world of technology, machines too are learning and adapting, mimicking the human cognitive process in a field known as machine learning. It's a realm where computers learn from data without being explicitly programmed, adapting and improving their performance as they gain more experience. Now imagine a subset of machine learning where machines not only learn from their experiences, but also adapt their actions based on the rewards or penalties they receive. Sounds intriguing, right? This is exactly what reinforcement learning is all about. It's a type of machine learning where an agent learns to make decisions by taking actions in an environment to achieve a goal. The agent gets rewarded or penalized for its actions, and through this process of trial and error, it learns the best strategy or policy to achieve its goal. Drawing parallels with our lives, think of how we learn a new game. We don't start off as experts. We try different strategies, make mistakes, learn from them, and gradually get better. Similarly, in reinforcement learning, the agent starts with no knowledge of the environment. It explores, makes mistakes, learns from them, and eventually figures out the best strategy to reach its goal. Just as we learn from our experiences, machines too can learn and adapt through a process known as reinforcement learning. It's a fascinating world where machines not only mimic human cognitive processes, but also have the potential to surpass human performance in various tasks. So what exactly is reinforcement learning? It's a type of machine learning that has an exciting twist. Imagine a creature exploring an unknown environment, learning from its experiences and constantly improving its future actions. This creature is what we call an agent, and this environment is its world to interact with. That, in a nutshell, is the magic of reinforcement learning. The agent, whether it's a robot, a software program, or even a mouse in a maze, makes decisions by taking actions. These actions change the agent's current state or situation. For example, if our agent is a chess-playing AI, the state could be the current arrangement of chess pieces, and an action could be moving a pawn forward. Now here's where it gets interesting. The agent doesn't just randomly decide on actions. It's guided by the outcomes of its past actions, which we call rewards. These rewards can be positive or negative. For instance, if our chess-playing AI wins a game, it receives a positive reward. But if it loses, it gets a negative reward. Over time, the agent learns to associate certain actions in certain states with these rewards. It begins to understand which moves lead to victory and which ones spell defeat. This learning process is a fascinating dance between trial and error and strategic decision-making. The agent constantly explores new actions to find potentially higher rewards while also exploiting its existing knowledge to make smart choices. It's like playing a game of chess where you're constantly learning and adapting, making each move better than the last. But remember, the goal isn't just to win one game. It's about winning as many games as possible. The agent seeks to maximize its total reward over time. It's not just about immediate gratification, but about long-term success. The agent wants to make the best possible decisions in each state to reap the most rewards. In essence, reinforcement learning is about learning the best actions to take in different situations to maximize rewards. It's a journey of exploration, learning, and constant improvement. It's about becoming the best version of the agent you can be, one decision at a time. Now that we know what reinforcement learning is, how does it work? The process of reinforcement learning follows a step-by-step procedure that's not unlike how we humans learn. It all begins with the observation of the environment. Imagine our machine, or agent as it's often called, in a new environment. It doesn't know what to do initially, so it starts by observing. It takes in the state of its surroundings, noting the variables that define the environment. This is its first step into the unknown. Next comes decision-making. Based on its observation, the agent makes a decision. It's like a child deciding whether to touch a hot stove or not. But unlike a child, our agent doesn't have innate instincts. It uses a policy, a kind of guidebook, to decide what action to take. This policy can be as simple as a set of rules or as complex as a deep learning model. Once the decision is made, the agent takes action. It interacts with the environment like a chess player making a move. The action changes the state of the environment, leading to a new observation. Now here's where things get interesting. After taking action, the agent gets feedback. This feedback comes in the form of a reward or penalty, depending on whether the action was beneficial or detrimental. It's like getting a candy for a job well done or a timeout for misbehaving. The final step is learning. Based on the feedback, the agent updates its policy. If the action led to a reward, the agent is more likely to repeat the action in similar situations. If it led to a penalty, the agent tries to avoid the action in the future. This learning process is iterative, repeating over and over until the agent masters the environment. Through this process, the machine progressively improves its actions based on the rewards and penalties it receives. It's like learning to ride a bike. You start off wobbly, but with practice, you get better and better, until eventually you're zooming down the street with ease. That's the beauty of reinforcement learning. A key dilemma in reinforcement learning is the trade-off between exploration and exploitation. But what does that mean? Well, imagine you've discovered a restaurant that serves the best sushi you've ever tasted. Do you keep going back to that same restaurant, or do you try a new one in hopes of finding something even better? That's the essence of the exploration versus exploitation dilemma in reinforcement learning. Exploration, as the name suggests, is all about seeking out the unknown. In our sushi restaurant scenario, it's trying new places. In reinforcement learning, it's when the agent tries different actions, even if they might not lead to an immediate reward. The goal here is to learn more about the environment and possibly discover more rewarding outcomes in the long run. On the flip side, we have exploitation. This is sticking with what we know, or in the sushi context, going back to that restaurant you already love. In reinforcement learning, exploitation is when the agent chooses actions that are known to yield good results based on its current knowledge. The aim is to maximize the immediate reward. Now, you might be wondering, why not just stick to what works? Why risk the unknown? Here's the catch. If an agent only exploits, it could miss out on potentially better options. Using our sushi analogy, what if there's a restaurant out there that's even better than your favorite one? You'll never know unless you explore. But if an agent only explores, it could end up wasting a lot of time and resources on less rewarding actions. It's like trying a new sushi place every night and never going back to the one you loved. So the trick is to balance exploration and exploitation. This allows the agent to learn about its environment while also ensuring it doesn't miss out on immediate rewards. It's a bit like trying a new sushi place once a week while still visiting your favorite one. Balancing exploration and exploitation allows the agent to learn effectively without getting stuck in suboptimal solutions. Reinforcement learning is not just a theoretical concept. It has real-world implications. Let's delve into the practical applications of reinforcement learning. It's fascinating to see how these algorithms can be applied in various fields. Starting with robotics, reinforcement learning plays an integral role. Robots learn to perform complex tasks, from simple movement to manipulation of objects, all through reinforcement learning. These robots aren't programmed with specific instructions. Instead, they learn through trial and error, much like a toddler learning to walk. Yes, the robots stumble and fall, but each time they get better, learning from their previous mistakes. In the gaming world, reinforcement learning has made significant strides. Remember AlphaGo, the AI that defeated the world champion Go player? That was reinforcement learning in action. The program played millions of games against itself, learning with each victory and defeat, ultimately mastering the game to a level unattained by human players. In healthcare, reinforcement learning is used to personalize treatment plans. Each patient is different, and therefore requires a unique approach. Reinforcement learning helps in determining the best treatment plan for individual patients, considering their unique health condition and response to different treatments. The finance sector also benefits from reinforcement learning. It's used in portfolio management, where the goal is to maximize returns and minimize risk. Reinforcement learning helps in determining the best investment strategy, considering the dynamic nature of the financial markets. There are many more applications of reinforcement learning, ranging from self-driving cars to energy management, and even in recommendation systems, which suggest the movies we watch or the music we listen to. And it doesn't stop there. With advances in technology and computing power, the applications of reinforcement learning are only set to increase. As you can see, reinforcement learning has the potential to revolutionize many sectors. Despite its potential, reinforcement learning does come with its set of challenges. As is the case with many groundbreaking technologies, there are some hurdles to overcome when it comes to implementing reinforcement learning effectively. One of the primary challenges is the complexity involved. In reinforcement learning, an agent learns from the environment by interacting with it and receiving rewards for performing certain actions. However, the environment can be incredibly complex, with countless variables and possible states. This complexity can make it difficult for an agent to learn effectively and efficiently. Another significant challenge is the computational resources required for reinforcement learning. Training an agent to learn from its environment can be a resource-intensive process, requiring powerful hardware and sophisticated algorithms. This can potentially limit the accessibility of reinforcement learning, as not everyone has access to the necessary resources. In addition, reinforcement learning also requires a vast amount of data. This is because the agent must explore the environment extensively to learn which actions will lead to the most rewarding outcomes. However, obtaining this large volume of data can be a daunting task, especially in real-world scenarios where data collection can be time-consuming, costly, and potentially intrusive. Furthermore, there's the challenge of the curse of dimensionality. This refers to the exponential increase in computational complexity as the number of variables or dimensions in the problem increases. In reinforcement learning, as the state and action spaces grow, the complexity of learning and decision-making processes also grows exponentially. But it's not all doom and gloom. Yes, these challenges are real, and they are significant, but they are not insurmountable. As we speak, researchers across the globe are tirelessly working on innovative solutions to these issues. From developing more efficient algorithms to leveraging advances in hardware technology, the field is continuously evolving and adapting. While these challenges exist, continuous research and development in this field are helping to overcome them. So, where is reinforcement learning heading? A question that piques the curiosity of many. As we step into the future, the possibilities of reinforcement learning seem limitless. From driving the development of intelligent machines to shaping the way we interact with technology, its potential is immense. Imagine a world where machines can learn, adapt, and make decisions independently. This is not science fiction anymore. Reinforcement learning is paving the way for such a reality. It is the key to creating intelligent machines that can not only understand our needs, but also respond to them effectively. Reinforcement learning could also revolutionize the way we solve complex problems. As it continues to evolve, we might see it being used to tackle some of the most challenging issues of our time, like climate change or global health crises. By learning from trial and error, these systems could devise innovative solutions that humans might not have thought of. Moreover, reinforcement learning has the potential to transform our everyday lives. Think about smart homes that can learn your preferences and adjust the settings accordingly, or self-driving cars that can navigate through traffic without human intervention. These are not just concepts anymore. They are becoming a reality, thanks to the advancements in reinforcement learning. However, it's not just about creating intelligent machines or solving complex problems. Reinforcement learning could also play a significant role in democratizing access to technology. By making machines more intuitive and user-friendly, it can help bridge the digital divide and ensure that everyone can benefit from the technological advancements. As we move forward, one thing is certain. The future of reinforcement learning is not just about the technology itself. It's about how this technology can be harnessed to create a better, more inclusive world. And while there are still challenges to overcome, the potential benefits far outweigh the hurdles. With more research and innovation, we can expect to see even more breakthroughs in the field of reinforcement learning. The future of reinforcement learning is promising, and we can expect to see more breakthroughs in this field. So, as we continue to explore the uncharted territories of this fascinating field, let's buckle up and enjoy the ride. So, we've covered quite a bit about reinforcement learning today. We started with the importance of adaptation in learning, laying the foundation for our understanding of this complex but fascinating field. We then dove into the basics, unraveling the essence of reinforcement learning and its process. We explored the delicate balance between exploration and exploitation, a crucial dynamic in the journey of learning. We examined the diverse applications of reinforcement learning, from gaming to healthcare, proving its versatility and potential. We also acknowledged the challenges in this field, understanding that there are still mountains to climb and problems to solve. We ended on a hopeful note, envisioning the future of reinforcement learning, where we can expect to see even more innovative applications and advancements. As we continue to learn and adapt, so do our machines, and reinforcement learning is a testament to that.